Alrighty, my mathematicians, it's time to start looking at proportion tables. And after we look at tables and determining if they're proportional or not, we're going to also look at the constant of proportionality. And if we look at the definition for the constant of proportionality, it says the constant ratio of one variable to another to which it is proportional. To me, that sounds kind of wordy. So bottom line, it just means unit rate. So constant of proportionality and unit rate mean the very same thing. That means how much is it for one can of drink? How much is it for one Starburst? How fast can I run in one lap? So one is going to always be your denominator or the bottom number when we're talking about a ratio. So real quickly, before we start with our tables, we're going to refresh our memory on if I have 7/8 and 1/2, and I want to know, are these two ratios proportional? Remember, the shortcut way that we did this is we looked at our diagonals and we said, well, okay, this is 14 and this is 8, so no, they are not proportional. Now, if we had multiplied and got the same number, like if both of them had been 8, then we would have said, yes, they are proportional, okay? So what we're going to look at today are two types of tables. We're going to look at horizontal and vertical tables, okay, because we could see them both ways. And we want to know, are they proportional or not? Now, this is not difficult. We just have to make sure that we're looking at the correct numbers. So hopefully, I'm going to use a sticky note and see if that'll make it a little bit easier for us to visualize what we're doing. So if I look at this, and the way this is set up, it looks almost like a proportion already. So if I just look at this part, so I would have 5/10 and 10/20. Well, if I multiply those diagonals, 10 times 10 is 100 and 5 times 20 is 100. So that tells me this part is proportional. But I need to double check because sometimes the numbers will switch up on us and confuse us. So I've done the first one. So now I can cover up, and now I need to do the next proportion. So I just have to, and you can probably do this on the calculator instead of jotting every one down, but I'm just going to write them all down so that we can see them easier. So if we multiply this diagonal, we get 300. And if I multiply 20 times 15, I'm also going to get 300. So I know, again, this set is proportional. So then I'm going to go to the next proportion. Okay? So if I go to the next proportion, all I'm going to do is slide this over one, and you just keep going step by step by step. So now we've got this proportion. So I'm going to have to move my sticky notes and stuff all around. I kind of got a mess here, don't I? So now I've got 15/30 and 20/40. So if I do my diagonals, 20 and 30 make 600, and I'm pretty sure 15 times 40 is 600, but if I want to just double check it, I've got, what am I doing here? I'm getting lost in my own talking. 15 times 40. All right, that is 600. So that tells me that this section is also proportional. So I keep going. So I'm going to go down one more. And finally, I'm at the last one. So if I check this one, I've got 20/40 and 25/50. So if I check these diagonals, I'm going to get 1,000 and 1,000. So I know that they are proportional. Now, some of you may have looked at this and said, well, each one of those is a half. And you could do that. You could do that as well, because then you know they're proportional because they all simplify to the same thing. So there's lots of different ways to determine if they're proportional or not, but I'm sticking with this way because that's going to lead us into when we have some of these numbers missing in just a little while. Okay, so again, we're going to look at our diagonals. So to start with, we're going to look at the 3 and the 24 and the 7 over 56. So if I do 3 over 24 and 7 over 56, I can find my calculator here. So if I do 3 times 56, that's 168. And then I'm going to do 24 times 7. And that's 168. So that part is proportional. So then I could go to the next part. So I'm going to go over 1 and cover this one up. So I have to go proportion by proportion. So 7 over 56 and 12 over 96. So if I punch in, I'm going to slide this over so you can see my calculator also. 7 times 96, we got 672, and then 12 times 56, we got 672. So far we are still proportional, but we need to slide over 1 and check the next one. So now I've got 12 over 96 and 19 over 171. I'm going to slide this over again so you can see my calculator. So if we multiply our diagonals, 12 times 171, which is 2052, and then 96 times 19, which is 1824. So then that tells us no, that this particular table is not proportional. So this table would be no. So I don't even have to finish it because I already got that they were different. So this table is no. Now I'm going to see if I can find the first table that I did. The first table that I did was yes. Okay? So then I'm going to do the same concept, except for this time my numbers are not horizontal, they're vertical. So if I look at this first one, this is like 1 over 2 and 7 over 14. So if I multiply my diagonals, I get 14 and 14. So that tells me that these first two would be proportional. So if I cover up that first one and keep going down, so I'm going to go down 1. So now I've got 2 over 3 and 14 over 21. So if I multiply this, that's going to give me 42, and that gives me 42 also. So I know that, yes, I am still proportional. So we're going to go down to the last one. See, I keep covering up and going down one at a time. So now I've got 3 over 4 and 21 over 28. Well, this one's 84. That's pretty easy to do in our head. If we wanted to double check, though, 3 times 28, 28 times 3, and that also gives us 84. So that means that, yes, this entire table is proportional. So we could do yes for that one. Okay? So now we've got one more table to check, and that's all we're doing is going through and checking piece by piece by piece. So I'm going to start at the top with 9. I got a decimal, but don't let that scare you. 9 over 6 and 58.5 over 39. So 39 times 9. So I did this diagonal and I get 351. Okay, now let's do this other diagonal, which is 6 times 58.5, which is 351. Okay, so my first set would be proportional. So now I'm going to slide down 1. So I'm going to slide my paper over, and I'm going to slide my sticky note down, just so that I'm only looking at just a little bit at a time so I don't get confused. So 6 over 17 and 39 over 110.5. Multiply my diagonals. So I've got 110.5 times 6, and that's going to give me 663. And then I've got 17 times 39. And so I am still proportional. So now I have to go down to the last one. So I'm going to slide my sticky note down. So 17 over 45 and 110.5 over 292.5. So then if I do 17 times 292.5, I get a big number, 4972.5, 4,972.5. And then 45 times 110.5, 4972.5. So then that means, yes, this table is also proportional. So I ended up with 3 yeses and 1 no. So now if I go back, if I have a answer of no, if it's not proportional, like this one is not proportional, then there's no way I'm going to have a unit rate that's constant. Okay? So now we're going to look real quickly at how do I find the unit rate for the constant of proportionality. And the easiest way to do this, and if we were in class, we may take longer and try to figure out and talk more about the reasoning behind it. But if we take y over x, if we take y divided by x, so whenever we do tables, you normally have x and then y. So if I do 7 divided by 1, I'm obviously going to get 7. So now 14 divided by 2, and I'm going to get 7. So I'm going to do all of these. So 21 divided by 3, and I get 7. If I do 28 divided by 4, I'm going to get 7. So this tells me that my unit rate, or my constant of proportionality, is 7. Okay? Now, if I went back to this one and I divided all these out, then all of my numbers would not be the same, and then that would also tell me that it's not proportional. Okay? So let's look at this one real quickly. Let's look at 58.5. Oops, excuse me. 58.5 divided by 9, and I get 6.5. Now if I do 39 divided by 6, 6.5. Remember, it's y, or it's not a very good y, divided by x. So this first column is x, and the second column is y. So now I'm going to do these last two and make sure they're both 6.5, and that tells me my unit rate is 6.5. So 110.5 divided by 17, and that gives me 6.5. And then the last one, 292.5 divided by 45. And again, I got 6.5. So my constant of proportionality, or my unit rate, is going to be this 6.5. Okay? So one last one where you can try this by yourself. Again, we've got x and y. So we want to do y divided by x, or make a ratio if you want to put it in as a fraction, or it's just easier for me to divide. So if we do 10 divided by 5, I think most of you already know what that is 2. Same thing here. If I do 20 divided by 10, 30 divided by 15, I'm not going to take the time to punch all them in, and that's going to give me 2 and 2. So again, my constant of proportionality, or my unit rate, for this table is 2. So today you only have to determine, is it proportional, yes or no, or true or false. This would be yes or true. And then you have to determine, if it is a yes, then what is the unit rate? So for this answer it would be yes, and the unit rate is 2. For this one it would be yes, and the unit rate is 6.5, or the constant of proportion.